Okay, this video is why do activated platelets increase cancer? Okay, so the first part of it is because the platelets here are these yellow cells, and this cell that's sort of maroon reddish, this is a cancer cell. When cancer cells break into the circulation, into the blood vessels, they are often surrounded by activated platelets. And this is if somebody has a reason for these platelets to be activated. They can be activated by excessive psychological stress. There's other reasons why platelets can be activated. But activated platelets have a tendency to encircle the cancer cell. And that's actually bad because when a natural killer cell comes along, a lymphocyte, it will try to remove the cancer cell, but it first has to check for the identity of the cancer cell. And so when it's trying to bind to the cancer cell, instead all it binds to is these platelets that are blocking access to the cancer cell. So the natural killer cell says, "Oh, nothing here but normal platelets," and it doesn't do anything to the cancer cell. So chronically activated platelets increases the risk of metastatic cancer spread. Oh, one other thing I was going to talk about, I'm going to talk about this in a separate lecture, but just a reminder, everybody knows cancer tends to feed on glucose. There's increased glucose type 1 transporters. They're not insulin dependent. They're in the plasma membrane, and they basically suck up glucose like a vacuum from the blood. And so more glucose gets into cancer cells. Cancer cells take up about 100 times more glucose than do regular cells. And of course, in a cancer cell, classically with the Warburg effect, the glucose is converted to pyruvate, and then the pyruvate to lactate. The lactate's expelled into the extracellular environment, makes it acidic. Sometimes there can be some aerobic metabolism, in which case the pyruvate it's decarboxylated, feeds into Krebs cycle with a 2-carbon unit that combines with oxaloacetate, a 4-carbon unit, to make a C6 citric acid, a citrate acid cycle. But okay, why am I going through all this? Here's why. Because at the bottom here is glutamine. And glutamine is the most common amino acid. It's non-essential. And the cancer can run everything off of glutamine. So that's real important. Even if you diminish glucose, cancer can still grow off of glutamine. So you can't win the game against cancer simply by restricting glucose. And the brain needs glucose, the red blood cells need glucose, some of your kidney cells only run on glucose. So you're not going to win the game only by thinking about glucose with cancer. Glutamine can do everything glucose can do and more because it contains a nitrogen. It's converted to glutamate, and that enters at alpha-ketoglutarate in the Krebs cycle. To replace the intermediates of Krebs cycles, there's a word for that. It's called anaplerotic anaplerosis. So I just want to remind you, because for anything we talk about cancer, you have to know that. Glutamine can replace the Krebs cycle intermediates and keep cancer going, and it doesn't even need glucose. Okay, that's real important. All right, so we already saw this cell. All right, let me get, and that's when we're talking about how platelets can hide cancer. Now here's an article about platelet-mediated protection of cancer cells from immune surveillance. So in addition to a mechanical blockage to hide the platelet from, covering up the platelet, to hide it from the NK cells, the platelets are the main source in the human body of something called transforming growth factor beta, and that will also have an immunosuppressive effect on the NK cells. So the platelets are a powerful immune suppressant. We know that excessive psychological stress, caffeine, sleep deprivation, all of those things will increase platelet activation and therefore increase transforming growth factor beta, and that will decrease immune function, the immune system's ability to remove cancer cells. And normally just even a 1-gram tumor can shed over millions of cancer cells a day, like 3 million a day. So you got to have a functional immune system. You don't want lots of platelet activation blocking them. Okay, so this is just from that same article. It says the impact of transforming growth factor beta on T cells and NK cells indicated by solid arrow. So it shows the activated platelets and then the little, flat edge, so it's blocking the NK cell function. And then, so this is to emphasize that effect from transforming growth factor beta. The tumor cells themselves have some activating effect on platelets through the release of ADP and tissue factor. Okay, but all right, so that's the main point I wanted to make, is just activated platelets can increase the risk of cancer spread by causing immune surveillance and blockage of NK cell access to the tumor cells to recognize them as foreign and abnormal and thus remove them.